Welcome to today's episode of PaperWave. I'm your host, Onyx. Today, we're diving into an exciting journey through pioneering cancer research. Joining us is the author of the paper, Jiaxi Wu, to discuss their groundbreaking work on IL-2 therapy for cancer. Welcome, Jiaxi.
Thank you for having me. I'm excited to be here.
To kick things off, could you provide an introduction to IL-2 therapy for cancer?
Sure. Interleukin-2, or IL-2, is a cytokine that plays a critical role in regulating the immune system. It has been used in cancer therapy due to its ability to stimulate the growth of immune cells that can attack tumors. However, traditional IL-2 therapy has significant clinical limitations due to severe toxicity.
I see. And your paper presents some solutions to these limitations, correct?
Yes, exactly. Our research introduces a PD-1-targeted, receptor-masked IL-2 immunocytokine known as PD-1 IL-2. This new therapeutic approach aims to enhance anti-tumor efficacy while reducing systemic toxicity.
That sounds promising. Can you explain what receptor-masked IL-2 immunocytokines are?
Receptor-masked IL-2 immunocytokines are engineered molecules that temporarily inactivate IL-2 by masking it with its receptor subunits. This design reduces unwanted interactions with non-target cells, thereby minimizing systemic effects while allowing reactivation in the tumor microenvironment.
Now that we've introduced the concept, let's delve deeper into the mechanisms behind IL-2RA engagement. Jiaxi, could you explain the importance of IL-2RA engagement in your study?
Of course. IL-2RA engagement is crucial for the anti-tumor activity of systemic IL-2 therapy. In previous studies, IL-2RA engagement by IL-2 was found to be critical for stimulating tumor-reactive T cells effectively and controlling tumor growth.
That's very insightful. You mentioned anti-tumor activity. How does systemic IL-2 therapy contribute to this?
Systemic IL-2 therapy stimulates the expansion of CD8 plus T cells and natural killer NK cells, which are crucial for anti-tumor immunity. However, modifications to IL-2, such as IL-2 muteins with reduced IL-2RA binding, have shown limited anti-tumor efficacy.
Interesting. Speaking of modifications, how do wild-type IL-2 and IL-2 muteins differ in this context?
Wild-type IL-2 engages IL-2RA efficiently, leading to potent anti-tumor effects. In contrast, IL-2 mutants that do not bind IL-2RA as effectively may expand certain immune cells but are less effective in tumor reduction.
And what is the role of IL-2RA specifically in expanding CD8 plus T cells and NK cells?
IL-2RA plays a key role in targeting IL-2 to tumor-reactive T cells within the tumor microenvironment, facilitating their proliferation and activation. This targeting helps in the effective expansion of CD8 plus T cells and NK cells within the tumor, enhancing the anti-tumor response.
Let's move on to the engineering and characterization of the PD-1 IL-2RA IL-2 immunocytokine. Jiaxi, can you provide an overview of the engineering process for PD-1 IL-2RA IL-2?
Certainly. The PD-1 IL-2RA IL-2 was engineered by fusing the IL-2RA and IL-2 moiety to the C-terminus of an anti-PD-1 antibody. This design allows the molecule to selectively reconstitute IL-2 activity on PD-1 plus T cells by using the IL-2RA ligand-binding domain as a receptor mask to attenuate IL-2 activity until it reaches PD-1 plus cells.
That's fascinating. What role do the ligand-binding domains of IL-2RA and IL-2RB play in this process?
The ligand-binding domains of IL-2RA and IL-2RB, which bind IL-2 with higher affinity, are used to create the receptor mask. This masking dampens IL-2 activity for both the dimeric and trimeric IL-2 receptors, allowing for localized activation of IL-2RA-BG trimeric receptor on PD-1 plus T cells.
How were these fusion constructs evaluated?
We used surface plasmon resonance, SPR, and other binding assays to evaluate the constructs. These assays revealed that our receptor-masked IL-2 molecules showed reduced IL-2 activity in the presence of the mask, but retained the ability to bind IL-2RA when unmasked.
And what did you find regarding the binding affinity and activity of these IL-2 fusion proteins?
Our results show that PD-1 IL-2 demonstrated strong binding to IL-2RA G cells compared to IL-2RB G cells, indicating the critical role of IL-2RA in enhanced activity. This selective binding and reconstitution of IL-2 activity on PD-1 plus T cells were crucial for the immunocytokine's performance.